Hey everyone, and welcome back. Today we're diving into something that sounds, well, a little deceptively simple at first. Data-oriented programming in Java. We've got excerpts from Brian Goetz's article on InfoQ,
Yeah,
and trust me, it gets way more interesting than it might seem when you first hear that title.
it really is.
Mm-hmm.
We often think about Java and we think about these big, complex applications, right?
Mm-hmm.
Big systems
Mm-hmm.
and object-oriented programming, OOP is great for that kind of stuff. But then when you start thinking about all these smaller services that are handling maybe a lot of data or in a very direct way, OOP can feel a bit clumsy.
Yeah.
It can feel like you're using a sledgehammer to crack a nut.
Like when you try to take a pile of JSON data and then you're like, all right, I guess I gotta cram all this into a tiny little object somehow.
Exactly.
Yeah.
And that's where data-oriented programming comes in,
Okay.
or
Oh,
DOP.
DOP, all right.
And so the idea here is instead of forcing your data into the structure of objects all the time, you kind of let the data guide the way that you structure your code.
So it's almost like embracing the data's natural form, whatever that might be,
Yeah.
instead of trying to I don't know, I guess contort it into these objects.
Yeah.
But this is Java we're talking about, right?
Right.
This isn't exactly a language known for being super flexible or data centric. So how does this even work?
Well, and that's what's really interesting is that Java has been evolving, and it's added features specifically to make data-oriented programming not just possible, but actually really elegant.
Okay.
So you've got things like records and sealed classes and pattern matching. And these might sound a little intimidating,
Yeah.
but they're really just tools that let you handle data with a lot more precision and clarity than maybe you could in the past.
Okay, so let's break those down a bit because I've played around with records a little bit that streamlined classes basically, right? For just holding data.
That's a great way to think about it.
But how do they fit into this whole DOP approach?
So think of records as kind of like purpose-built containers for your data. And they help you model the information in a very clear, immutable way.
Right.
Which is a really core principle of data-oriented programming.
Okay.
You're essentially saying, with a record, this data represents a single, unchanging concept.
Right.
And that makes your code much easier to reason about.
Okay, that makes sense. What about sealed classes? Because those have always seemed a bit mysterious to me.
Yeah.
How do they play into this?
Sealed classes are kind of like gatekeepers for your data types.
Okay.
So imagine you're writing a function, and it could have, one of a few different outcomes. Maybe it's success, maybe it's failure, maybe it's some other specific state.
Right.
Sealed classes let you define those states explicitly,
Okay.
so you know exactly what to expect, and you can handle each case really gracefully.
So no more I've done this a million times where you just have a generic result object
Right.
and then you're just kind of well, I hope it's this kind of result, not that kind of result.
Exactly. You're just kind of guessing. Yeah. And then you've got pattern matching on top of that, which lets you work with those different states in a really, really nice way.
Okay.
It's kind of like a supercharged switch statement
Right.
that's type aware and can actually unpack the data within your sealed classes in a really elegant way.
Interesting.
Yeah.
I'm starting to see how these pieces kind of fit together now.
Yeah.
But I need to see it to believe it, I think.
Well-
How does this actually work in real world code?
Yeah. Well, Dutz gives some really, really good examples. And I think one that we can all relate to is he talks about handling command line options in Java,
Yeah.
which if you've ever done it can be a bit of a pain.
Try not to think about it, honestly.
Yeah, it usually ends up as just like this big tangled mess of if statements and string parsing. And,
Oh, yeah. Tons of conditional statements.
yeah, and it's not pretty.
No.
But he shows how with data-oriented programming, you can use these sealed classes to define each possible command line option
Okay.
and the data associated with it.
Oh.
And then with pattern matching, you can just handle each option cleanly and safely without all those nested ifs and the potential for errors that come with that.
That almost sounds, dare I say, enjoyable.
It can be.
All right, so you've piqued my curiosity. What other kind of pain points does he tackle with this DOP magic?
So another one he dives into is complex return types, which I think anybody who's worked with Java for a while has probably struggled with.
Yeah, for sure.
And it can be a real headache.
Ah, yes, complex return types.
Yeah.
Those moments when you're just staring at your code and you're like, I guess I could cram everything into an array, or maybe I just use null to signal something went wrong. It's like trying to fit a square peg into a round hole.
Right.
You can make it work.
Yeah.
But it's not pretty, and it's probably going to cause you problems down the line.
It's not very expressive, is it?
Hmm.
You lose that ability to clearly state what you intend
Totally.
when you're just trying to kind of jam everything into one type.
So how do we address this? Like this Gordian knot of return values.
Well, this is where data-oriented programming
Ugh.
can bring some real elegance to the table.
Okay.
And Coots introduces the concept of algebraic data types,
Okay.
or ADTs for short.
ADTs.
I know that sounds intimidating.
It does. It sounds a little scary.
It sounds very, very mathy and theoretical.
Yes.
But it's actually a pretty intuitive concept once you kind of wrap your head around it.
Okay, so demystify it for us.
All right, so imagine being able to define a type that says this function, it can return an integer, and if it returns an integer, that means success, but it could also return a string, and if it returns a string, that means something went wrong, and here's the error message,
Okay.
right?
Yeah.
So it lets you model these different outcome possibilities explicitly.
Interesting.
And your code becomes, it's almost like self-documenting at that point, because you can, it's very clear what the different possibilities are.
It's like those old choose your own adventure books,
Right.
but for your code.
Exactly.
Or it's like, each path is clear. You're not left guessing like, well, what happens if this thing returns this weird value? What am I supposed to do with it?
Right. It's like you said, it's self-documenting.
Yeah.
It tells you exactly what's going on.
And I feel like this would be especially useful when you're dealing with data that could take multiple forms, which kind of brings us to, external data formats like JSON.
Oh, absolutely.
Because that's often, I feel like, where I run into these problems with return types is you're talking to some API or something, and it's like, well, it might return this, but it also might return that. And you're like, ugh, okay, now I gotta figure out how to jam that into my Java code.
Right. It's all this data, kind of floating around out there in the world, and it's not always in a format that Java loves.
Yeah, and then you end up with a million nested objects, and you're doing all these null checks, and it's just like...
Oh, yeah, the amount of null checks,
it's painful.
it can be really, really painful.
But, so I guess, are we saying that ADTs could help with that?
That's exactly what Gertz suggests.
Right.
He says that you can use these algebraic data types to actually model your JSON data
Interesting.
in a way that's very, very natural.
Okay.
You're basically saying, here are the different shapes my JSON could have.
Right.
And then you can work with that data in a way that just feels natural to Java and, more importantly, natural to you as the developer.
So it's almost like we're, instead of fighting with that JSON structure and trying to just kind of I don't know, force it into our Java code, we're taking a step back and we're like, okay, how do we represent this in a way that makes sense?
Right.
That's clear,
Yeah.
That's not going to be confusing 6 months from now when I look at this code again.
It's about making the code reflect the way that you think about the problem.
I like that.
Yeah.
Okay, so we're shifting our perspective a little bit here. We are.
We're moving away from this idea of everything has to be an object. And if it's not an object, I don't know what to do with it, to this more data-centric view of, let the data guide the way we structure the code. But I'm guessing, this has to have, there's got to be other benefits here, right?
Oh, absolutely.
Besides just saving us from those late night debugging sessions, which, believe me, I appreciate. I will take all the help I can get in that department.
Right. Who needs more of those?
Yeah, exactly. But what else? What else we got?
Well, so I think one of the really big ones is readability.
Okay.
When your code clearly reflects the shape of the data, it's not just more readable for you, it's more readable for anybody else who has to work on that code base.
It's like the difference between trying to decipher a cryptic message versus, reading a well-written paragraph or something.
Exactly. It takes all that guesswork out of it.
Yeah.
Because it's right there. It's explicit.
Right.
And this also helps with testing. Oh, interesting. Okay.
Because when you know exactly what to expect from your data,
right,
it's so much easier to write really good tests.
It's like they say, clear code, clear mind or something like that. But this all sounds, I don't know, almost too good to be true. Is DOP the answer to everything? Should we all just throw out OOP and just do this all the time now?
Well, that's an important point, and Goots actually addresses that in the article, It's not that data-oriented programming is here to replace object-oriented programming.
Okay.
It's more about having, the right tool for the job, right?
Right.
OMP is still great. It's really good at modeling complex systems,
Yeah.
relationships, especially when you need, those really clear boundaries.
Like building the structure of your whole application.
Exactly.
You wouldn't want to, I mean, I can't imagine trying to model that with just a bunch of, data structures, no matter how elegant they are.
Exactly. You still need those tools,
Yeah.
at the higher levels.
Yeah.
But, within that larger structure,
Yeah.
you've got all these smaller services, these components that are really about data transformation, maybe data validation.
Right.
That's where DOP can really shine.
It's about, I guess, recognizing those places, those little pockets where this data-centric approach can really help.
Yeah.
And you know what I thought was really interesting, and maybe this is me reading too much into it, but
Yeah.
he focuses on Java, right? This article is about data-oriented programming in Java, but
Right.
it feels like these principles, this way of thinking about the problem, it's bigger than just Java.
Absolutely, yeah. And he actually hints at that a little bit in the article, too. He kind of emphasizes that, this is not just about, here are the specific language features in Java that enable you to do this.
Okay.
It's really more about a shift in mindset,
Interesting.
about how you approach problems from this kind of data-first mentality.
So even if you're not a Java programmer, even if your language of choice doesn't have records or sealed classes,
Right.
there's still something to be learned here about, thinking about your data in a different way.
Exactly. It's really about, asking yourself, like, how can I represent this data in its most natural form?
Right.
How can I make my code reflect the way that I think about this problem as a developer?
Yeah, it's almost like learning a new martial art or something, where
I like that.
there's the specific moves, the specific techniques you learn, but then there's also this underlying philosophy,
Yeah.
this way of thinking about how you approach, any challenge that you might face.
It changes the way you see the world,
Exactly.
or in this case, the way that you see your code
Yeah.
and the way you interact with data.
That's a good way to kind of bring this all together. So as we wrap up this deep dive into data-oriented programming in Java, here's a thought-provoking question that maybe we can all kind of take with us.
All right. I like it. Lay it on me.
Where else in your coding life could you apply this data-first philosophy? Maybe it's how you design an API, or how you structure your database, or, even just how you approach a problem when you sit down to write code every day.
Yeah, that's a really good question.
It's something to think about.
It really makes you kind of reconsider some assumptions,
I think so.
which, I mean, that's kind of the point of exploring these ideas, right?
That's the beauty of the deep dive.
That's what we're here for,
Exactly.
to kind of shake things up a little bit.
Well, thank you for joining us on this exploration of DOP. We hope you've learned something, maybe a new way of looking at things, and until next time.